today we're going to look at creating networks from tweets with the software Mozdeh that we use in this module. And we're going to look at different types of network that we can create from tweets and other web text formats. This is just a reminder about how to gather tweets with Mozdeh if you haven't used it already. You can download Mozdeh free from http://mozdeh.wlv.ac.uk, and it should work on any Windows computer, including your home laptop. When you start Mozdeh, you have to enter a project name into the screen on the left and then click the Start New Project button. After that, you need to enter a set of search terms to get tweets about these queries. So you can choose your own search terms to start with, anything that you're interested in that you think people might tweet about. So popular words are a better choice than very rare words for this to get enough data to start with. If you want to gather lots of tweets, then check the Keep Searching Until Button Clicked option, and that will allow you to collect tweets for a longer time. Otherwise it will just collect tweets once, with a maximum of 2,000 tweets per query. Then click the Start Data Collection button. You'll then be asked to log into Twitter, so you'll need your own Twitter username. So you'll need to join Twitter if you haven't already, and it's free, but you do need to be a member to use Mozdeh to gather tweets. So follow the instructions on screen, and then you'll be given a pin in your web browser that you need to copy to Mozdeh, sorry. So copy that number into Mozdeh and click OK, and then Mozdeh will have permission from Twitter to gather tweets. While it's collecting tweets, you'll see the query that's being used at the top left hand corner of the screen. So this might take a few minutes to send all your queries to Twitter and then get tweets matching your queries back from Twitter. So Twitter will only return queries from the past week, so any topic that was discussed a long time ago won't get many results today. Mozdeh stores the tweets in the project folder that it creates when it starts. If you selected the continuous monitoring option, then you'll need to click the Stop Monitoring button. Otherwise it will automatically stop monitoring once it's got one set of tweets after a couple of minutes. When it's finished, it's going to ask you how you want it to process the data. And at this stage it doesn't really make much difference which options you choose, but I'm going to show you the recommended options. So the first question is filter out duplicate tweets, so the recommended option is yes. And I'll ask you which language, so pick one unless you submitted queries in other languages mentioned in the box here, and then click OK to ask Mozdeh to process the data with the options requested. You'll be asked another set of options, so just accept the default here and click OK. And then when Mozdeh is ready, it sends you to the search screen. So it's finished collecting tweets and it's now saved the tweets onto your local computer, and it's also processed the tweets so that it can analyze them in different ways. So one simple thing you can do with the tweets is search them. So you could enter a query into the Mozdeh search box at the top of the screen, click search, and then it lists the first 40 odd tweets matching your query in the box. But we're not interested in searching tweets, we're interested in creating networks. So if you want to create networks from the tweets that you've gathered through Mozdeh, then Mozdeh has a networks menu with lots of different options for creating networks from the tweets collected. So the rest of this presentation is going to go through using these network options and background information. So basic principles of network drawing that are relevant to Mozdeh. So first of all, you need to decide what type of network you need to draw, and in general you need to decide what's the purpose of your analysis. We don't discuss that in this module, and then choose a network that matches that purpose. And choose how many nodes to include. So more than 50 nodes often creates a mess. So for this module, I recommend that you always draw a network with 50 or less nodes. They're clearer and quicker to create as well. In this module, we're going to draw our networks with Mozdeh or Webmetric Analyst, mainly with Mozdeh. And just as general practical advice, Mozdeh will draw the networks for you, but it will allow you to fine-tune the network positions, the positions of the nodes, to make the diagram tidier. So that's useful if you're showing your network to other people. And you can also colour the nodes with clustering or even relevant facets. If you want to colour code, say, nodes from one country to show them different from nodes from another country, Mozdeh gives you the option to override the default colours of nodes. So first of all, we're going to look at Twitter conversation networks. Conversation networks from Twitter show information about who tweets to whom. Here's an example. This example shows a network that can be built from one tweet, but usually we use thousands of tweets to draw a network. But the process is the same as for one tweet. So this tweet, you can see, mentions 4 other Twitter accounts in the one tweet. So we're going to ignore the last one and create a network from the first 3. So we have this tweet creates a connection: Lab Left Voice tweeting to Jenny Jensek, Lab Left Voice tweeting to Jeremy Corbyn, Lab Left Voice tweeting to John McDonnell MP. So Lab Left Voice is tweeting to these because they're mentioned in the network. So this is the network that we could draw from this tweet, ignoring the last account. So Lab Left Voice with an arrow to Jenny Jensek, Jeremy Corbyn and John McDonnell MP, indicating that Lab Left Voice has tweeted to these 3. So we've turned this one tweet into a picture showing connections between these 4 tweeters. So Twitter conversation networks, the purpose is to illustrate Twitter communication between users. For some reason you might be interested to see how people are talking to each other, and the Twitter network would be helpful for that, the Twitter conversation network. So this is often drawn for politics, to show which politicians are talking to which other politicians, at least on Twitter. The nodes are the individual Twitter usernames, the usernames of the tweeters, as we've seen in the previous example, and an arrow from a tweeter to another tweeter indicates that the first one has mentioned the second name's username in their tweet. And often we have far more than 50 users, so we usually have a procedure to select which users we're going to add to the network, and it can be the ones with the most arrows pointing to them, so the most mentioned, the most arrows pointing from them, or the most connections overall. Or we might have a predefined set, such as all the Labour MPs or all the Tory MPs. So this type of network, a Twitter conversation network, works best for sets of users that know each other. So it works well for MPs because they know each other, but this would be not very useful for Wolves fans, for example, because most Wolves fans don't know each other, so they won't tweet to each other. So you get a very sparse network with very few connections in. So how do we create this in Mozdeh? So from the networks menu is the top option, create networks of user connections in tweets for the top end users, and we select option number 1, largest minimum number of tweets from user to someone, tweets to user from someone. So it's we're going to draw the nodes in the network. The nodes in the network are going to be the tweeters that have either got the most tweets from them or the most tweets to them. So they're the most tweeted to or from in the network. So that's the type 1. And this is a network of this type drawn by Mozdeh, and this is for tweets collected from a collection of tweets about people that express annoyance. So people that use an expression around annoyance. And this isn't a very good network because most of the tweeters don't know each other. So there are only a few clusters. There are 4 clusters of people that have connections, and 2 of the clusters are just 2 people. So most of the nodes have no connections. So it does show some patterns, but I think it's not particularly useful. I think this is a much more useful network. This is a network of Unicef users, people that work for Unicef or associated with Unicef. So you can see a lot more connections in this network. So almost everyone, in fact I think everyone, is connected to at least one other person or tweeter in this network. So it's a much more informative network, and we can see nearer the centre of the diagram are people that are Twitter users anyway, that have more connections than people at the outside. The ones at the outside tend to have 1 connection, and the ones closer to the middle tend to have a lot of connections. It's still an untidy network though. We've got overlapping labels and lots of crossing lines, so it's a bit untidy, but we can see some patterns here. The second type of network is a co-tweeted network. This is a strange mathematical network that we can create from tweets. It's an undirected network. That means no arrows on the lines, of users mentioned in the same tweet as each other. So the definition is that the thickness of the line between user A and user B is proportional to the number of tweets containing both @A and @B. So line thickness is proportional to the number of tweets mentioning both users or containing both usernames. It's produced in Mozdeh by the same command as above, just a different option. It's rarely useful, but sometimes it's the only option for creating a appropriate network. So here's an exercise. Here's a collection of 3 tweets, one from Gurjit, one from Lee, one from Grace, and one from Amalia. I'd like you to complete these 2 networks. The first one for a Twitter conversation network, and the second one for a co-tweeted network, and then we can compare the 2. So pause the presentation now and continue when you've created these 2 networks. Okay, so the direct tweeting network, there's an arrow from each user to each other user when the first one mentions the second one in a tweet. So Gurjit's tweet is, "Hey @Lee and @Grace, how are you?" So there's a line from Gurjit to Lee and a line from Gurjit to Grace. And then Lee says, "Hi @Gurjit, have you seen the news?" So there's a arrow from Lee to Gurjit. Grace says, "Hello @Gurjit," so there's an arrow from Grace to Gurjit. And Amalia says, "Hey @Lee, @Gurjit and @Grace," so there are arrows from Amalia to Lee, Gurjit and Grace. So you could have drawn a double-headed arrow between Grace and Gurjit and between Gurjit and Lee. That's fine. Sometimes we draw 2 single arrows, sometimes we draw a double-headed arrow, so that's no problem. So the co-tweeted network, this is a trickier one, I think anyway. So this is my co-tweeted network. So from the Gurjit tweet, Gurjit says, "Hey @Lee and @Grace." So Lee and Grace are mentioned in the same tweet. So we have to draw a line, not an arrow, a line between Lee and Grace. So you'll see a line between Lee and Grace. And then Lee says, "Hi @Gurjit, have you seen the news?" There's only one person mentioned in that tweet, so we can't use that one. Grace says, "Hello @Gurjit." Again, only one person in that tweet, so we can't use that one. And then Amalia says, "Hey @Lee, @Gurjit, @Grace." So this creates a connection between @Lee and @Gurjit. So we draw a line between Lee and Gurjit. @Lee and @Grace, they're in the same tweet, so we draw a line between Lee and Grace. There was already a line So we draw a double thickness line to reflect the fact that Lee and Grace have twice been mentioned in the same tweet, one from Gurjit and one from Amalia. And then we've got at Gurjit and at Grace at the end, so there's a line between Gurjit and Grace in the diagram, a thin line because they're only mentioned together in one tweet. So in this diagram, the co-tweeted network, there's a line between two people when they both occur in the same tweet, and the line is thicker when the two usernames occur more than once in the same tweet. So the thickness should be proportional to the number of tweets that the two users co-occur in. Okay, so did you get those answers? Here's an example of a co-tweeted network created by Mozdeh. This is not a very useful network, I think, because there are only two co-tweeted connections here. So there's two different Ed Sheerans connected together, I don't know why, and Ed Sheeran's connected to YouTube, but no one else. So in this example, only 3 different YouTube users were mentioned in the same tweets. Okay, another type of network we can create with Mozdeh is a tweet similarity network. So this creates a network that reflects how similar the tweets are that are written by specific tweeters. So there's a line between two tweeters, a line not an arrow, between two tweeters if their tweets contain similar words. So the thicker the line, a thicker line is drawn if the two users use more words in common, and there's no line if the users use no words in common. So if you have a look at the diagram drawn for tweet similarity in the bottom right hand corner, can you see the reason why the two lines have been drawn? So I'll pause the presentation now, and restart it when you think you've got an answer. So the Gurjit Lee link is there, connection is there, because they both use the word Rwanda in a tweet. So the similarity is based on the fact that they've both used the word Rwanda. And Gurjit and Grace, similarity, they both use the word water. And Grace and Amalia, Grace and Lee and Amalia don't use any of the same words in their tweets, so there's no line between them. Okay, so this is just a very simple example with one tweet each, but in practice we compare all the tweets of individuals and we get lines of very varying thicknesses depending on the number of words that the users have in common. And in fact we use a more complicated algorithm to decide how thick the line should be, which we'll cover later in the module. Is the TF-IDF algorithm. So the purpose of a tweet similarity network is to illustrate the similarity of the tweets between users if you collect tweets by username, but if you run several queries you can also draw a network of the same type where the nodes are queries, tweets matching each query, and the line thickness is proportional to the similarity of the text in the tweets for each query. And the nodes are either Twitter usernames or the queries. The connections are lines with widths reflecting text similarity, and the text similarity measure that we use is TF-IDF cosine similarity, which we're going to see about later on in the module. We select either all labels or a list of labels for this, so we don't have an idea of selecting the top labels or the top nodes as we have previously, but we usually select all relevant labels or a set of labels that we're interested in. So each label will be either a Twitter username or a query. So don't use this if you've just got one user or just one query, because it won't produce anything. To produce one of these, it's in Mozdeh, it's the networks menu, and it's the fourth option down, make networks of post TDF-IDF cosine similarity between labels, colour code by majority gender of poster. And you get lots of questions to ask when you select this option. First of all, it asks you for a list of terms to make the network from. That's the top right hand corner box. So that could be the usernames or queries. And then the other options you can leave blank. You can accept the default, and they should produce a reasonable network. So when Mozdeh builds these networks, in fact it builds 6 networks. So when you ask for one network, it actually draws 6 networks. So these networks it draws are, first of all, exactly what you've asked for, a complete network showing all the nodes and arrows that you've asked for. But because this is often not very useful, it draws 5 more networks that it thinks might be more useful to you because it's easy to identify the patterns in them. So the second network it draws is a sparse network, a 75% sparse network, and for this one it only includes lines that are at least 75% as strong as the thickest line. So this gets rid of all the thin lines. Thin and medium strength lines, it gets rid of them, and it only includes the strongest lines. And then it repeats that for 90%, 95% and 99%, so it's drawing increasingly few lines in these sparse networks, and it's only drawing the very strongest ones. So that can be helpful at identifying really the core connections in your network. And then the 6th thing it draws is a maximal spanning tree, where it draws the strongest lines first, and it doesn't draw connections that make loops. We'll come back to that later and explain what a maximal spanning tree network is. So here's an example of a complete network. So this is a cosine similarity network of Unicef tweeters, and I think every pair of nodes has a line between it. The lines vary in thickness, but every pair of nodes has a line between it, so it's a bit of a messy graph. We can see the biggest connections are between Unicef Media and Unicef Education, and also a bit between Unicef Education and Voices of Youth, but it's a bit of a messy network. So here line thickness is proportional to tweet text similarity. So this is saying that Unicef Education and Unicef Media write tweets that contain them are most similar in terms of the words they use. This is a 75% sparse network. It's the same set of nodes and it's the same process to produce the graph, but the thinnest lines have been removed now, and only lines with at least 75% of the data of the thickest line are drawn. So we can see the most important connections, the most important similarities, and not the rest. And similarly for the 90 and 95% and 99%. So I promised to tell you what a maximal spanning tree is, so I'll explain that now. This is a mathematical algorithm, a simple mathematical algorithm to prune the network. It draws the fewest lines to connect all nodes into a single network. And the process is first, draw the strongest undrawn connection unless it creates a loop. If it creates a loop, throw it away. And then you just repeat that until you've drawn all the lines or thrown them away. So it's really quite a simple 2-step algorithm. And it drastically simplifies networks, but it should only be used in emergencies when other methods don't produce a useful network. So this is an example of a maximum spanning tree network for the Unicef dataset. So if you look at this, you'll see there are no loops. You can't go round in a circle in the network, and that's the way that a maximal spanning tree works. So I'd like you to look at this table of data and draw two networks from it. One, a standard co-tweet network. So this table reports the number of co-tweets between 5 users A, B, C, D and E. I'd like you to first draw on the left a standard co-tweet network and then turn that network into a maximal spanning tree on the right. So pause the presentation now and then I'll show my answer when you're ready. So your basic network should look like this. So for example, there's a 1 in the cell entry for row A, column B. So I've drawn a line of thickness 1 between A and B. There's a 4 for A and C. So I've drawn a thick line between A and C. There's a 7 between A and D. So I've drawn a very thick line between A and D. And I've carried on through the network, drawing a line with the thickness represented in the network. So this is a similarity network, and we can see that A and D's tweets are the most similar and A and C's are the second most similar, and third most similar are B and D, and fourth D and C. So how does the maximal spanning tree work? So for the maximal spanning tree, we start with the thickest connection, and that's the 7 one, and we draw that unless it makes a loop. It doesn't, so we keep that one. Then we go on to the second thickest connection, which is the 4 AC. We draw that unless it makes a loop, which it doesn't, so we keep that one. And then the third thickest connection is the AC. Sorry, we've done that one, the CD. So we should draw the CD connection, but we can't draw the CD connection because it would then create a loop, A, C, D, and back to A again. So instead we throw away the CD connection. We can't have any loops in a maximal spanning tree. And then we go on to the connections of strength 2, and there are 2 of those. So our third drawing is the connections of strength 2, and they don't create any loops, so they're both fine. And then we go on to the weakest connections. AB would create a loop though, so ADBA, so we throw that away. And BC would create a loop. If we drew the BC line, we'd get a loop ADBCA, so we throw that away. And this is the final maximal spanning tree. So you'll see that the network doesn't contain any loops. I'll just say a little bit about sparse networks. So we've used the word sparse networks. So sparse networks only draw the thickest lines, and in Mozdeh the cutoff is the percentage of maximum thickness. And it's useful when we have a network in which most of the nodes connect, or even all of them connect, as often happens with the text similarity networks. And the sparse networks reveal just the strongest connection patterns, as we've perhaps seen with the Unicef example. And Mozdeh draws 4 different sparse networks, and there's no rule to tell you which one is the best one. You just have to look at them and decide which one for you is the most informative about your data. So it's just your own guesswork really. So here's some examples of sparse networks. So this is a network of museum Twitter accounts, the Twitter accounts of museums. Each dot is a museum Twitter account, and every line between dots is indicates some kind of text similarity between their tweets. So I think this diagram is pretty useless. You can see a bit of clustering in it, but it's just a mess. So this is a 95 sparse network of the same data, so it's the same data. And now for this network we can see some pattern. We can see that there are lots of Twitter users that don't write similar tweets to the rest, or not very similar, and then there's a central cluster of Twitter users that do tend to write similar tweets to others in the cluster, and there's even a central cluster of maybe 5 or 6 or 7 users that write very similar tweets. So we can see a clear pattern in this data. So I would say that this 95% sparse network is much more informative than the previous network, and we've made it more informative paradoxically by deleting a lot of information. We've deleted a lot of the connected lines, so we've lost information, but the visualization has become more informative because we can focus on the core, the most important information. So we've shown that there's a central set of similar tweeters. So to summarize this session, we've looked at 3 types of Twitter networks. Twitter conversation networks where one user tweets to another, or where 2 users are mentioned in the same tweet, Cotweeted network. And we've looked at the text similarity network, which we can draw between tweeters or between queries. And we've shown the possibility to use both sparse networks and maximal spanning trees to highlight the core network structure of a network. So I hope that made sense. Please let me know if you have any questions.